Hi, welcome to our discussion on atmospheric dynamics. In this video, we're going to talk about the thermal wind. And before we talk about the thermal wind, we need to talk about the shear of the wind, and specifically the vertical shear of the horizontal wind. So what shear means, it's a change of wind direction or wind speed. And specifically, we're talking about the vertical shear. So that would be a change in the wind as you go up through the atmosphere. Change in wind with height, both in speed and direction. So what this is, the vertical shear of the horizontal wind, mathematically, it's a vector difference between the winds at two different levels, one lower level and one upper level. In this diagram or this picture, it shows two winds at different altitudes, one at 850 millibars, another one at 500 millibars. So you've got a difference in height between those two levels, and you got a difference in the wind speed and the wind direction. There are a lot of things that cause the vertical shear of the horizontal wind. Of course, friction. We talked about friction last time in one of our videos. We discussed the different layers of the atmosphere, how there's a surface layer and a friction layer. We looked at the surface layer and we said that the wind increases with height. It changes speed, but it really doesn't change much in direction in the surface layer. But in the friction layer, this is where the wind changes clockwise with height. So looking at a weather chart, at the surface, just above the surface at the anemometer level, or in other words, about 30 feet up in the air. In this example on the left, you see the winds are blowing kind of from the south, and then higher in the atmosphere, they switch around to the southwest. So they change direction and they change speed. And that means that the winds turn clockwise with height as a result of friction. And we can plot this on a hodograph. And we saw this before. We called this hodograph the Ekman spiral. So the representation of the wind vectors that show the wind changing with height in the friction layer produces the Ekman spiral. But there are other things that can cause a vertical shear in the horizontal wind. And one of them is the horizontal temperature gradient. And that produces a concept called the thermal wind. So by definition, the thermal wind is the mean wind shear vector in geostrophic balance with the gradient of mean temperature of a layer bounded by two isobaric surfaces. What does that mean? Well, to make it a little more simple, the thermal wind is an imaginary wind. So it's not a real wind. It's one that helps us visualize what's going on in the atmosphere. It helps us relate the temperature gradient in a layer to the vertical shear, meaning that wherever you see a temperature gradient, there should also be vertical shear. Vertical shear meaning wind changing direction and or speed with height. So this is the equation that we had. We saw that vertical shear is the change in wind speed with height, dv dz. And that's just the difference between the upper and lower. So we're going to define this vertical shear as the thermal wind. And we can derive a relationship for the thermal wind using the geostrophic wind and the geostrophic wind components. I'm not going to bore you with that derivation, but this is what the result looks like. And it shows on the left-hand side the thermal wind, and on the right-hand side of the equation a lot of things that include the pressure, two different pressure levels. Also the delta HT dz is the temperature gradient in a layer. dz is that layer. And then a couple of other variables, R being the gas constant and F being the Earth's vorticity or the Coriolis parameter. So the thermal wind, this equation shows us that there should be vertical shear in a layer because of a horizontal temperature gradient. So it gives us a concept. It helps us visualize the wind or an imaginary wind that is produced by a temperature gradient in a layer. So we'll talk more about this in the next video.